Okay, here we go. So, welcome everybody to my talk. I have to say I was a little bit surprised when this talk was selected to be the keynote because it has nothing to do with AI. Well, anyway. But we are all still web developers. AI hasn't yet replaced us all. And it turns out that there's a revolution taking place in web development as well. A revolution that, unlike AI, is very much flying under the radar. And that's the comeback of RPC in modern web frameworks. And in order to talk about this comeback, we need to kind of speak about what is RPC? Why did it go away? Why is it now coming back? And most importantly, what does it actually mean for us as web developers? And in order to explain all that, I would like to start with a story. Okay, so Sam Selikoff gave a talk 2 years ago about the future of React, a future that is now our present. And in this talk, he showed, amongst other things, this slide. It was actually towards the end of his talk, but when this slide was shown and then shared, the collective tech Twitter kind of lost its mind. Everybody went nuts. Like the X blew up. And a lot of people got all in a huff because they saw that piece of SQL with a parameter in it, and they thought, oh no, SQL injection. Well, they were actually wrong, because they were unfamiliar with tagged template literals, which in this case sanitize the SQL before it's actually executed. So there is no security problem in this particular case. Other developers got really annoyed or excited, you decide, because they were seeing a lack of separation of concerns. They were seeing the data layer intermixed with the UI layer. But that's not a problem either, because in React really is all about mixing concerns when they are related to each other. That's kind of like the whole point of React. So now I can finally talk about what got me all excited about this when I saw this slide. And what got me excited is this: the fact that backend code was invoked by a front-end component, the button, as a function call. So you see when the form action is assigned a function, an async function, and that function is executed when that button is clicked, but it's executed on the back end because that's where it can actually run the SQL. And what actually signifies that is that userver, and we will talk about it in a minute. And I got all excited because this was the first time that I was seeing RPC in a full stack application in a very long time. Okay then, so what is RPC? Well, here is my definition for RPC, and I'd like to simply read it. RPC is remote procedure call, is a method of invoking a service or obtaining data from another process, even on another computer across the network, using a function call paradigm. In other words, you talk to code somewhere else, but you talk to it as if it were a function, which at this point you might say that a better name might have been remote function call, but I guess RFC was already taken. So how does RPC look like when we compare it to something like REST, which we all know and love? Well, the top part is REST, and we see that we first make a very explicit network operation, in this case a fetch, and passing the parameter very explicitly using the URL. And then when we get the response, we actually very explicitly parse that response in order to obtain the data that we're interested in. Whereas with RPC, it looks like a function call. Get by ID could be a local function, but in this case, it's actually a remote function. And the parameter is passed just like a regular function call parameter. In other words, we were working at a much higher level of abstraction. So what are the benefits of RPC? So first of all, as I mentioned, it looks like a function call, it works like a function call. In other words, it's a very familiar paradigm for us as developers. It's one we use all the time. Also, as I said, it's a higher level of abstraction. We don't need to explicitly deal with serialization. We don't need to explicitly deal with the network layer. This is all automatically done for us. Another big advantage is that it's type safe. That means that, and I will show this in a demo later on, but it means that the parameters and the return values are properly validated, just like with local function calls. And another key advantage is that it's symmetric for the client and the server. On the server, it's just a regular function call. On the client, it looks like a regular function call, but it's automatically sent across the wire. But the code on the server and the code on the client that invokes this functionality looks the same. But as I mentioned, RPC went away. Why, you might ask? If this is such a great paradigm, why did we actually lose it? And we did lose it. It was really big in the 90s, and then it kind of disappeared when the web happened. And there were several reasons for that. First of all, the legacy RPC protocols that we used to have back in the 90s, for those of you who are old enough, protocols like Corba or DCOM, they were incompatible with the web. Browsers could not support them. Proxies didn't work with them. They just couldn't traverse firewalls. It just couldn't work. Another problem is that if RPC is one of the main advantages is the type checking, the static typing, well, JavaScript is not statically typed. So what's the value, what's the benefit of using RPC with JavaScript? Also, JavaScript does not have a blocking operation. And if you're performing something that looks like a function call across the network, you need to block, or seems like it blocks, until the response actually arrives in order to mimic a function call behavior. But JavaScript did not have blocking operation, or does not have blocking operations. Also, there was no automatic generation of stubs. JavaScript is just interpreted. It's not compiled, so you just run it. Well, with RPC, you want this mechanism that handles all the serialization and network for you, and that requires generating the code that does it, and you didn't get that with JavaScript. But then the ecosystem changed. You know, things move forward. Things happen in the web. First of all, TypeScript was introduced. Well, whoa, that's a long time ago. Can you think about it? Like 13 years ago. Wow. Anyway, TypeScript brought with it type safety. So all of a sudden, we could actually leverage the fact that RPC provides us with static type checking. Another advantage is that we got bundlers, sophisticated bundlers like Webpack and now Vite, and they can and actually do generate code during the build time. And that makes it possible to generate stubs that can handle the automatic serialization of the data, for example. Another advantage is the fact that we got await. Again, 8 years ago. Wow. And now we can actually mimic blocking calls. You await on that function call, and you don't continue or resume the execution of the calling code until the value actually returns, until the RPC completes. So with all of these, we then finally got RPC on the client side, or on full stack applications. And the first implementation of RPC was TRPC. TRPC was created in 2020, and its stated goal, this is on their website, is to easily build and consume fully type-safe APIs without schemas or code generation. They actually decided to forego the automatic code generation, and we will kind of see what the implications of this is or are. It's type-safe because it's built on TypeScript. It leverages TypeScript. In fact, TRPC is called TRPC because it's TypeScript remote procedure call. That's literally where its name comes from. And what's very significant about it was that it is framework agnostic. You know, we are at ReactNext, but we also love other frameworks. We love Vue, we love Solid, we love Qwik, and TRPC can literally work with all of them. It can, in fact, work with none of them whatsoever, and because it's totally agnostic to the framework that you're currently using. But funnily enough, I actually now prefer a different library called ORPC, which is a new library, kind of new. I call it, it's not official, but I kind of refer to it as the better TRPC. And why is it better? It has all the advantages of TRPC, plus a few additional ones. First of all, it has built-in OpenAPI support. In fact, this is where the O in ORPC comes from, which means that any RPC endpoint built in ORPC can be made to be an OpenAPI endpoint, so you can also call it using an OpenAPI client. It also has somewhat cleaner APIs and has really improved error handling built on exceptions. And at this point in time, who wants to see a demo? You want to see some code? Let's see some code. Okay then. So I've got a simple client-server application. Maybe I can start by actually showing how it looks. It's kind of a CRUD application that shows users, and you can add users to kind of this users database. So let's do npm run dev. It's really simple. So this is what it looks like. We've got a list of users built in. For each user, we have the name and an email, and we can add additional users. For example, I'll add myself. Oh, I deleted myself. And it now reloaded, and I was added to the list. Okay then, let's look at the actual code. So we've got a backend and a front end. Let's start with the backend. First of all, the backend defines a few types. I'm actually using Zod. Zod is used by both TRPC and ORPC, or integrates with them. And the benefit is that I get both static type checking, but also runtime type checking. And I don't have to define the types twice because Zod can infer the TypeScript types from its schemas. So first of all, I create a user data schema, which has a name, which is a string that is at least 1 character long, an email. I infer the type from it. And I have a user schema in general, which also adds an ID. And then I simulate a database as simply an array of such users. And I added 2 operations, one to get all the users, and another one to add a user. Get all the users, for example, simply returns a clone of the array, and add a user simply pushes an additional user into the array, generating a unique ID for it. I create a router for ORPC. So and with a router is basically just an object that has both of these methods. And I use the ORPC API to tell it exactly what the parameters are, what the schema is. This enables both a runtime validation and build time validation. And I basically just hook it up to the HTTP server and pass. And I create a handler and pass the incoming request to the handler to be handled if the URL and the operation match. On the client side, and this is the beauty of the thing, let's look, for example, at the component that displays the list of the users. Is it big enough? Can you all see it? Okay. So all I do is first of all, I import the API, and I can get the promise of the get all, and if we look at the type, we can see that it's a promise that returns an array of the correct type. And I can use the new React use operator on that promise and get the actual correct type. So I got type inference on the client from the code that was defined on the server. In order to properly work, you probably want to do it in a monorepo, but this is like awesome. I don't need to do a as unknown as something in order to work with JSON blobs. I just get the proper type inference. Let's look, for example, at the add user. I pass in, I directly call the add method on the ORPC object, on the user's object, and I get proper completion and parameter validation. For example, if I decided that I want to add the age, you see that there's that red squiggly because there is no such property or such parameter in the function called arguments. So again, I get type validation, I get automatic completion, all the great things that I get with TypeScript, but across the wire. So this is really great. And we already saw how it works. Okay then, so back to the slides. I always almost accidentally click share when I want to click the slideshow. This is a really bad UI design in my opinion. But anyway. Okay then, but we saw that with the ORPC, it wasn't as seamless or as clean as it was in Sam's demo. We had to create these Zod schemas. We had to create the router. We had to explicitly create the handler. Whereas if we look here, there's no such thing. It just looks like a function call. And that's because of the magic of useServer. Because they have total control in Next.js or in React over the entire process, they created this magic scaffolding that does everything for you. So it's really kind of like happens really magically, and you don't have to deal with all the low-level stuff. We talked about the fact that TRPC and ORPC intentionally were very explicit about the scaffolding. Well, this is totally not the case with Next.js and React. But how does it work? It works because modern front-end frameworks have very sophisticated bundlers built into them. In fact, it's kind of the whole point. It automatically it looks at the same code base. When you're building a Next.js application, you're not separating really front-end from back-end. It's the same code base. And it needs to be able to build different bundles or different packages of code for the client and for the server. And in order to do this, it uses a very sophisticated bundler, and that bundler is able to look at instructions like useServer, like useClient, and so forth, and generate the code appropriately. So it automatically generates the stubs that perform all the magic, the routing, the handling that we saw explicitly before. Next.js is not really unique in this. This is really now a part of essentially every front-end framework almost. Next.js, as we said, has useServer. It also has useCache in order to control how caching works when you're making these RPC calls and other things. Solid has adopted useServer from Next.js and from React because Solid really strives to kind of look like Next.js, but they've intentionally removed some of the RSC restrictions that Next.js intentionally and explicitly has. For example, that inlining of useServer that we saw before in that Next.js demo can only work in React server components. In Solid, they removed that restriction. Qwik also has server functions. Instead of useServer, you wrap the function in server $, and they have a cool feature, which I will actually demo in a bit. So not with Qwik, but I'll still demo, so it's worthwhile to stay around and not leave yet. called streaming. 10 stack, if you've heard about it, it's really becoming popular in the React ecosystem. They use server functions that were kind of TRPC inspired, but with their own syntax. You wrap the remote function in create server fn, and Svelte has it as an experimental feature, at least the last time that I've heard. They like using file name extensions. So for the remote functions, you need to put them in a file that has a .remote.ts extension. And now it's time for another demo. So I mentioned streaming. So let's look at an example of what that actually means. But first of all, so I need to break out of this. And you know what? Before I break out of it, I want to show you the problem. So okay, so the page reloaded because we're using Vite, and Vite is really cool, but let's duplicate it. And now I'll add the user again. First of all, there's this annoying flash because it only updates the list after I add a new list. So it first adds a user, and then it explicitly gets all the list of all the updated users. And the second problem is that it only knows to get the list of updated users because it does it on the user add event. And as a result, that other tab did not update because it didn't get this client-side event. So how can I maybe keep things in sync and make the UI cleaner and nicer? Well, it turns out that RPC has streaming capability, kind of similar to GraphQL subscriptions, if you're familiar with them. So in order to see that in action, we will need to break again. And because I'm not going to write this code on the fly, I'll just switch to a different merge request. And let's look at how I changed the database functions. We still have the get all users and the add users, but I added another function called stream users. And stream users is a generator. And what it does is that it yields that entire list of users in an infinite kind of loop. It looks like an infinite loop. And then it waits on a promise that indicates a change happen. And when a change happens, it will yield the users again, and again wait for a change to happen. And on the client side, if I go to that users list, instead of using that use on a promise to explicitly get all the users, I now, in a use effect, have an async function called update users, which gets that stream and basically does a for wait loop on that generator. So we've got a generator running on the server and using iterators for it on the client. And it works across the network. And let's see how this actually works. Well, so again, we still have those two instances. Let me add myself again. First of all, it's much nicer, because we don't have to make the explicit call from the client after the update. The update is pushed from the server to the client in that stream. If I had a bit more time, I would actually show you the network tab. But the other cool thing is that it was pushed to all the subscribed users, so it's also updated in the second instance as well. And if I had another instance open on a different computer, it would update there as well. So RPC is really cool. I love RPC. I really enjoy using it. But that doesn't mean it doesn't have any downsides. So let's talk about the downsides of RPC and the things to watch out for. First of all, RPCs tend to be chatty protocols. This is not an inherent issue of RPC so much as it kind of encourages us to build chatty APIs on top of RPC. Why? Because of the fact that it mimics function calls. And we are used to making intentionally very thin function calls on the client side. The single responsibility principle. So we make a lot of function calls. Because function calls, the actual function call on the client side is very cheap. Well, here it isn't. It's across the wire. It's serialization. It can be really expensive. But it causes us to kind of build chatty protocols that make a lot of RPC calls in order to perform an operation. Related to that, and kind of highlighted in this image over here, is that it can encourage network waterfalls. Because again, instead of performing the same two operations in parallel and using something like promise all or await all resolved, we write them sequentially, await the first one and then await the second one. Because again, we think of them like function calls on the client side. So it can result in waterfalls if we're not careful. In fact, use cache was very much created in order to deal with waterfalls caused by this and other issues. It can result in a plurality of endpoints, especially when it's so easy, like we saw in Next.js, where you can just add the use server. You need some info from the server. Let's just create another RPC endpoint. And you can end up with a ton of RPC endpoints and little control over all of them. And a lot of times, the RPC implementations don't provide intentional support for controlling what the exact endpoint will be and what the method used will be. ORPC does, TRPC does, Next.js, for example, does not, as far as I know. And there's versioning issues. If you can just change an RPC endpoint, and all of a sudden, if a client is already up and running, you potentially break it because it's passing the wrong parameters or expecting the wrong return value. There's also potentially security liabilities associated with RPC. The static type checking. If we're using Zod, then we get runtime and also build time validation. But in a lot of RPC implementations, it's only build time verification, which means that you think you're getting security at runtime, but not really. Because the private APIs are publicly accessible. At the end of the day, these are HTTP endpoints that anybody can call. You have to remember that. Also, there are potentially issues of co-locating server and client code in the same repo, which can result in unintended visibility of code. Next.js has some really nice tools in order to prevent this, but this is still a mistake that you can make. So what are the takeaways from all of this? First of all, RPC is really cool in that it enables type-safe, certainly at build time, but potentially also at runtime, front-end to back-end and vice versa communication. It's really integrated and easy to use. You want to call some functionality on the back-end, you want to get some data, it feels like a function call away. But be mindful of the pitfalls and liabilities that I just mentioned. If you want a general purpose RPC solution that's agnostic to whatever framework you happen to be using, maybe you're just using React on the client side and Node or Nest.js on the back end, well, ORPC is a great solution for that. But if you're using something like Next.js, I highly recommend using the built-in RPC capabilities that are available in that framework and not throwing in something else. And with that, everybody, I conclude my the most important message. RPC, it's now part of, as you saw, it's now part of almost every framework, which means it's a tool that's available to you right now. So learn it, understand it, and use it. Thank you very much.